In this video, let's look at what happens when we have the product of a sum and a difference of two binomials. See if we can observe any patterns that might evolve out of it. Here's what I mean by a sum and a difference. If I have x and 2 in both of these binomials, but I allow one of them to be positive and one of them to negative, that's what I'm referring to as the product of a sum and a difference. In our previous lesson, we learned that a binomial squared or times itself always gave an answer that was a trinomial or had three terms. What happens here? Well, let's do our FOIL expansion for it. Our first terms multiplied together give x squared. Our outsides give negative 2x. But this time our insides give positive 2x. And our lasts, because we have a positive times a negative, yield a negative. Now when we examine this polynomial or string of terms, we notice some like terms exist, the ones in the center. Not only are they like, they're exact opposites, negative 2x's and positive 2x's, which means they perfectly cancel each other out. And we end up with an answer simply of x squared minus 4. Let's try this again using a different example. Let's create a binomial where the first term is identical, 4x, 4x, and the last term is identical, 3 and 3, except for its sign. Let's make one of them positive, one of them negative. In fact, this time let's swap it out so the negative one is first and the positive one is second, just to see what might happen. We recognize this as a binomial times a binomial, and so we need to apply the principles of FOIL in multiplying it out. Our firsts multiplied together give us 16x squared. Our outsides give us 12x. Our insides give us negative 12x. And our lasts, when we look at the signs and their values, give us negative 9. And again, I notice the same thing evolve, that the outside and the inside products end up being opposites of each other because of the fact that these signs are opposite too in the two binomials. So they cancel each other out. And I'm left with 16x squared minus 9. So let's look for some trends. How is the first term in the simplified result, so that's this one right here, how is it related to the first term in each binomial? Okay, well, we notice that this is simply the first term in the binomials squared. So it is the square of the first term in the binomials. And let's go to the last term in our answer. Here it is. I'm intentionally leaving the negative out because I'm looking for a specific pattern. How is that related to the values that were in these binomials before we intentionally added or changed it so that one of them was positive and one of them was negative? Well, again, it too is the square of the last term in the binomials if we ignore the signs. And that's important to note. Okay? So we're ignoring the sign in the answer and we're ignoring the signs in the original question as well. Okay? And then, why does our answer end up being a binomial in these scenarios instead of a trinomial? Well, I think you can see it's because the outside and the inside terms, because of the negative and positive patterns that we put into here, end up canceling each other out. Okay, so when we have a product of a sum and a difference, we end up with an answer that is a binomial instead of a trinomial. Okay, so this special scenario where we have the product of a sum and a difference gives us an answer that is always the square of the first terms, the square of the last terms, and subtracted by a negative sign. we have a special designation for this. This is called a difference of squares. A difference of squares of the terms that were present in the question. Okay, so a difference of squares is always the result of the product of a sum and a difference. And that's an important pattern to notice. Okay, enjoy your practice for 5.2. Start to recognize when you have perfect square trinomial answers, when you have difference of square answers, but more importantly, what types of questions generate those specific answers.